Hello students, welcome to my class. Today we are going to discuss few questions related to aldehyde, ketones and carboxylic acid, and this time the pattern is JEE main exam pattern. So let's start the question answer round. Now my first question is Fehling solution. This is completely theory based question. As we know, Benedict solution, Fehling solution, Tollens reagent all are used as a test for aldehyde and ketone, aromatic aldehyde, aliphatic aldehyde. So Fehling solution is, we people know, as I discussed during my lecture, that is copper, sulfate and Russell salt plus NaOH. So for question number 1, C is the correct option. Clear what I am telling? For question number 1, C is the correct option. Now friend, I am going to rub this part and we'll discuss the next one. Wait for a moment. The next one is treatment of propanaldehyde with dilute NaOH. Look at what is given here. Treatment of propanaldehyde, that is CH3, CH2 and CHO. Clear? On treatment with dilute NaOH, that is, we people say that is the base OH minus. What will happen? Check it out. It can be written like this: CH3, CH2, C double bond OH. Okay. If I take another mole, then what will happen? Check it out. Plus, that is, it can be written like this: CH2, CH here, put here CH3, then CH double bond O. This is the component. I have written this like this, 2 moles, and we people know in presence of base, this is a famous Aldol condensation. This one is alpha carbon. So this one is alpha hydrogen. It can be written like this, CHH. So this will add here. Yes, yes sir. So the product is CH3, CH2, yes, then CH, yes, then put here OH, yes, then CH, put here CH3, then CHO. This is the product. Now check it out, which one is the correct option. This one and this one. Okay. Now look at, that is CH3, CH2, CH3, CH2, CHOH, CH, CH3, CHO. Again CH3, CH2, CHOH, CH, CH3, CHO. So we can say that is, for this question, C is the correct option. Now friend, I am going to rub this part and we'll discuss the next question. Wait for a moment. Now let's move to the next question, that is question number 3. What is given here? Look at, formaldehyde gives an additive product with methyl magnesium iodide. What is given here? Read the question carefully. Formaldehyde, that is HCHO, clear to you, on gives an additive product with methyl magnesium iodide, CH3 MgI. Yes sir. Write down the product. What will happen? Look at what I am telling. It can be written like this: C double bond O, this one is H and this one is H. Clear to you? Now 2 possibilities here, that is, it will move here, then it will acquire negative sign and it will acquire positive sign. Yes sir. Now as we know, this one is acquire positive sign and this one will acquire negative sign. So this will move here. So the product is the intermediate, that is COMgI. Yes sir. HCOMgI, then put here CH3, then H. Clear? Now on hydrolysis, that is H2O in presence, as we know it will break like this, H plus OH minus. Now what will happen? This one is minus and this one is plus. So this OH plus will move towards O minus. So the product here is, look at, CH3 CH2 OH, and the byproduct is, check it out friend, that is CHOHI MgOHI. So what we say? We say the product in this case is ethyl alcohol. Clear? That is, the product in this case is ethyl alcohol. Now I'm moving here, check it out. For this question, we people can say ethyl alcohol is the main product. For question number 3, B is the correct option. Clear? Now I'm going to rub this part and we'll discuss the next one. Now let's move to the next one. Read the question that is given here. The enolic form of acetone. What is given? The enolic form of acetone contains. What is the keto and enol form? Do you remember? This one is keto, CS3 COO CS3. This one is ketone. And enol form, that is we all know these are in a dynamic form, that is CH2, the double bond C OH, then CH3. This is the enol keto form. This one is keto form, yes sir, and this one is enol form. Keto and enol. Now find out the number of lone pair of electron, that is the lone pair of electron. Clear? Now what is the question? The number of sigma, pi and lone pair. How many sigma bond here, how many pi bond, how many lone pair of electrons in keto and in enol form. Now check it out. If I write like this, that is C, put here H, put here H. Okay. Now C, this one is O, then this one is H, and this one C, H, H, and put here H. Clear? Now count the sigma bond. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can say that is 9 sigma bond. Clear to you? 9 sigma bond. Is it? Now what is pi bond? Here is CH2, that is 1 pi bond. We can write here that is 1 pi bond. Clear? Now number of electron, tell me sir. In this case 1 and 1, 2, that is 2 lone pairs of electron. What I'm telling, in this case there are 2 lone pair of electron. So the complete answer is, wait for a moment, that is 9 sigma bond, 1 pi bond and 2 lone pair of electron. So check it out, 9 sigma bond, 1 pi bond and 2 lone pair of electron. So for question number 4, A is the correct option. Again check, 9 sigma, 1 pi and 2 lone pair of electrons. So friend, I'm going to rub this part and we'll discuss the next one. Wait for a moment. Now let's move to the next segment, next question, that is the question number 5. That is what is given here. Look at the formation of cyanohydrine. What is given? The formation of cyanohydrine from a ketone is an example of, look at, this one is ketone, CH3 C double bond O CH3. Clear? Now what will happen? It will move here. Listen carefully, and this one is Cn minus cyanide. Now check the things very carefully. If this moves here, that is, it can be written like this, CH3O minus. Am I right? Yes, sir. Contain 2, 2, 4. Clear to you? And 2, 6. Minus sign contains. Now, it is CH3. And when treated with HCN, that is HCN, it gives you H plus and Cn minus here. Now, this Cn minus is nucleophile. Clear? It will attack here because carbon plus oxygen minus. So what will happen? Check it out. It gives you CH3, CO minus, then Cn and CH3. Now next one, the H plus attack on this oxygen, and the final product in this case we people can say, so the product is CH3, CH3, OH and Cn. Is it clear to you? What happened here? Double bond breaks and the addition of nucleophile take place. What I'm telling? Double bond breaks and the addition of nucleophile take place. If there is a addition of nucleophile, now check it out. Which one is the correct option? So for this question, that is nucleophilic addition reaction. So for question number 5, B is the correct option, that is nucleophilic addition reaction. I think these are very good question. You can easily solve if you have a command over the theory. Now let's move to the next question. Now next one, look at among formaldehyde, acetaldehyde and acetone. What I'm telling, among formaldehyde, acetaldehyde and acetone, the reactivity order towards nucleophilic addition reaction. If I talk about formaldehyde, HC, wait for a moment. It can be written like this. C double bond, here is H and this one is H. This one is formaldehyde. Yes, sir. Now CH3, this one is C, this one is H, double bond on. This one is acetaldehyde. Yes, sir. This one is C, this one is C, this one is C, double bond O. This one is ketone. Now what will happen? Addition of nucleophile take place. Then definitely that is there is a breaking of bond take place. As we know, as I told you during my lecture, if the number of alkyl group increases, then it restricts the addition of the nucleophile. That is, this is known as steric effect. What I am telling, in formaldehyde there is no presence of alkyl group, so nucleophile can easily attack on the carbonyl carbon. But in acetaldehyde there is a presence of one alkyl group, so it will take lesser time, it will take more time to attack. That is, it will hinder, it will restrict the addition of nucleophile if we compare the formaldehyde and acetaldehyde. If we move towards ketone, there is two alkyl group, so it will restrict the addition of nucleophile. Due to this reason, reactivity decreases when we move from top to bottom towards nucleophilic. This effect is known as steric effect. Second, that is electron donating, that is plus I effect. Here is one electron donating group, here is two, more plus I effect. More plus I effect, less tendency to attack of the nucleophile. So two effect, best one, that is steric effect. More the alkyl group, less is the tendency of nucleophile to attack on the carbonyl carbon. So what is the reactivity order? Sir, HCHO, CH3CHO, CH3, that is formaldehyde, acetaldehyde and acetone. This is the correct order of reactivity. So for question number 6, we people can say that is B is the correct option. Is it clear, friend? Now I am going to rub this part and we'll discuss the next one. Wait for a moment. Now look at, during reduction of aldehyde from hydrazine and potassium hydroxide, the first is the formation of. I am leaving this question for you. Think on it, how to solve this question. This is one of the simplest question. So read the question and try to solve it. So friend, tell me what will be the answer of this question. During the reduction of aldehyde with hydrazine, what is hydrazine? We people know this is NH2, NH2. This one is hydrazine. And according to the question, what is given here? During reduction of aldehyde with hydrazine and potassium hydroxide, the first is the formation. Write down the first of all aldehyde. What is aldehyde? See that this one is R and this one is H. Clear? Wait for a moment. This one is aldehyde. Okay. Now, on treatment with hydrazine, NH2, yes sir, NH2 in presence of KOH. Given here in presence of KOH. What will happen? Sir, the product is, remember, that is NH2, yes sir, and this one R and this one H, which on further heating release N2 and form CH. Here is H, then is R, and then is R. It is nothing but RCH. Check it out. 1, 2, 3, 4. That is RCH3. So what will happen? The question is, the first is the formation. The first one is this one. So how to write this? That is RCH double bond NH2. Am I right, friend? This is the correct option. So tell me what will happen. Now we can easily say, sir, for this question, that is A is the correct option. So for question number 1, that is A is the correct option. For question number 7, that is A is the correct option. Clear? Now I'm going to rub this part and we'll discuss the next one. Wait for a moment. Now, let's move to the next segment. Aldol condensation will not take place in. Tell me what will happen. Aldol condensation will not take place in. As we know, aldol, if there is a presence of alpha carbon, mean to say alpha hydrogen, then the carbonyl compound will perform aldol condensation. CH3CO CH3 will perform aldol condensation. So here also alpha carbon, that is alpha hydrogen. But if I talk about HCHO, look at here, that is the formaldehyde. In formaldehyde, we people know there is no presence of alpha hydrogen. That is also no presence of alpha carbon. So due to this reason, formaldehyde will not show aldol condensation. So for question number 8, that is A is the correct option. Clear, friend? Now I'm going to rub this part and we'll discuss the next one. Wait for a moment. let's move to the next question. The next question is question number 9. Acetic acid exists in dimer state in benzene. This is one of the simplest question and completely conceptual. What is acetic acid? That is CH3COOH. It generally exists in dimer form, CH3COOH whole twice. Why? What is the reason behind it? As we talk about the structure, that is the structure C double bond OH like this. So if I talk about the if I take second molecule of acetic acid, then look at very easily, there is a very maximum tendency to form hydrogen bond. Clear to you? If there is a tendency to form hydrogen bond, then they will associate, they will dimerize and form exist as in a dimer form. So it's very simple to conclude that for question number 9, why acetic acid exists in a dimer state? So due to the hydrogen bonding, oxygen and hydrogen, the link between hydrogen and most electronegative atom forms a hydrogen bond. So for question number 9, B is the correct option. Now friend, I'm going to wrap this part and we'll discuss the next segment. What will happen? Check it out. Now the next one is question number 10. When sucrose is heated with concentrated HNO3, what is given here? When sucrose is heated with concentrated HNO3 in presence of V2O5, the product formed is, the product form is very simple. You have to memorize, that is oxalic acid. This is GKGS type question. When sucrose is heated with concentrated HNO3 in presence of a catalyst vanadium oxide, the product form is oxalic acid. So for question number 10, it's very simple. D is the correct option. Clear? I think you can easily solve such kind of question. This is so simple. Now let's move to the revision. We'll revise the things again. What will happen? Check it out. That is, for question number 1, tell me what is Fehling solution. So it's very easy. The Fehling solution is copper sulfate and Russell salt plus NaOH. Now, what is treatment of propanaldehyde with dilute NaOH? As I told you, the product is CH3CH2CHOH CH3CHO. Yes. For question number 3, formaldehyde gives an additive product with methyl magnesium iodide, which on aqueous hydrolysis gives you, tell me sir, which on hydrolysis gives you, what I told you, ethyl alcohol. As I remember, it gives you ethyl alcohol. So B is the correct option. For question number 4, that is enolic form, 9 sigma, 1 pi and 2 lone pair of electrons. Therefore question number 4, A is the correct option. For question number 5, the formation of cyanohydrin from a ketone is an example of nucleophilic addition. That is for question number 5, B is the correct option. Now for question number 6, as I told you, that is 2-factor steric effect and plus I effect. So in this case, the order is HCHO, CH3CHO, CH3 whole twice CO. So for question number 6, B is the correct option. Now let's move to the question number 7. During reduction of aldehyde with hydrazine and potassium hydroxide, the first is the formation of, that is RCH. This is the famous reaction, Wolff-Kishner reduction. Clear to you? So for A is the correct option. Now aldol condensation will not take place. We all know, as I discussed many times, that is A, HCHO, formaldehyde. Now let's move to the question number 9. Acetic acid exists in a dimer state in benzene Due to the presence of hydrogen bonding. Now question number 10, this is simple. When sucrose is heated with concentrated HNO3 in presence of V2O5, the product form is oxalic acid, COH. So I think now you can easily solve such kind of question, is very easy to solve. So friend, this is the end of today's lecture. Thank you so much.